right, continuing through with some of these verifying identities of trig functions. Again, you need to know your Pythagorean trig functions. You have to be aware of your stuff, your reciprocal identities, your Pythagorean identities. So knowing that you know your stuff, let's see if you know what secant squared x minus 1 is. Secant squared x minus 1 is equivalent to tangent squared x. So it just has to be manipulated a little bit because we know that tan squared x plus 1 is equal to secant squared x. So that's how we get this. We're just manipulating this by subtracting the 1 over, and that way we know tan squared x is equal to secant squared x minus 1. And the same thing with this one right here, sine squared x minus 1, well, that's equal to negative cosine squared x, and that's where we get that negative. Again, sine squared x plus cosine squared x is equal to 1. So I know that if I have the negative 1, I need to bring the 1 over here and the cosine over here, and that's where we get sine squared x minus 1 equals negative cosine squared x. I also know that tan is sine over cosine, and how convenient that we're multiplying that with a cosine squared x. So when I cancel, I get negative sine squared x, and we wanted these two to match identically, and they did. All right, let's take a look at this one. This one looks really interesting. So if you read, the blue box that I was talking about earlier is not on page 360. I think it's on the page before, 359. But they kind of give you some hints. They say, try to find your Pythagorean identities. Try to put all your sines and all your tans and cotangents and secants and cosecants into sine and cosine. So I'm going to start this one out by putting this into 1 over sine. Well, when I'm adding or subtracting, like I'm doing, I do need a common denominator. I know my common denominator is going to be sine of x, so there's nothing that needs to multiply here. So I'm not even going to worry about that. But to make this over sine of x, I have to multiply by something by 1. I can multiply anything through by 1 and not change its value. So look on the top here. I have 1 minus sine squared of x. And remember, we're looking at this equaling cosine x times cotangent x. Hey. I know that 1 minus the sine of x squared is equal to the cosine squared of x. And all of that's going to be over sine. Again, I just want that to equal this. Now the funny thing is we get thrown off by this. On the top here in the numerator, I actually have 2 cosines. On the bottom, I have 1 sine, so we don't even think about how this can be split up. If I do split this up, notice that cosine over sine can be split up, and I know that cosine over sine is cotangent, and now they are totally equal. Cotangent of x times cosine of x, and that's equal to the cosine of x times cotangent of x. So there's a lot of different things. It's probably best if you take a look through some of the book examples in that box in section 5.2 and tell me what you think.